Let me show you. The 1970s salt giant, crime scene under the sea. Let's go straight to the crime scene. Summer of the early 1970s, the deep-sea drilling project's Glomar Challenger is lowering pipe through a quiet blue surface into what everyone assumed was just normal seafloor mud. Then the cores come up, gypsum capping thick halite, salt layered like a bakery stack, but not in a lagoon or a sabka. This is deep basin salt. The core photos look almost mundane, white, pinkish, translucent sections. But the lab notes read like a shock report. This shouldn't be here unless the basin was functionally cut off and evaporating at colossal scale. Now zoom out from the core barrels to the X-ray of the entire basin. Seismic profiles lighting up a basin-wide reflector, the M-Reflector, a bright, continuous horizon that cartographers of the subsurface began tracing across the western and eastern Mediterranean. That reflector isn't a rumor. It's a physical acoustic ping marking the salt giant's top. Tie that reflector to DSDP leg 13 holes, and you've got ground truth. Kilometer-scale evaporites widespread across deep floors. You don't build that in a slow, well-ventilated sea. You build that in a near-closed superbasin that's losing water faster than it's getting it. Here's what makes it weirder. Microfossils in and around those intervals blink in and out with missing sections and signs of desiccation stress. You see sapropel black layers elsewhere in the record, but right here, the evaporite logic takes over. Primary gypsum gives way to halite, and in places to potash, magnesium salts. That sequence tracks a brine climbing the evaporation ladder. It's chemistry as a stopwatch. The only way to time that much halite is to drop sea level, concentrate the brine, and repeat in pulses. Between packages, you catch erosion surfaces, breaks that whisper. It didn't dry once, it cycled. Now check the edges, the big rivers. The Nile carved down toward abyssal depths, with buried canyons imaged under the delta dropping well below present sea level. The Rhône, Ebro, and Po show overdeepened valleys heading seaward, their profiles not matching modern base levels. Those aren't lazy meanders, they're emergency exits for a basin whose floor stepped down and yanked river profiles with it. You can argue tectonics tilting shelves, but the geometry points to rapid base level fall punctuated by refill events. It looks like the drawdown took breaths. Every crime scene has a control point. Here, it's the Gibraltar Gate, a narrow sill, shallow by ocean standards, sitting at the interface of the Atlantic and the Alboran Western Mediterranean pocket. Make that sill a bit higher through uplift or a landslide choke, and the Atlantic-Med exchange throttles. Microseismicity and uplift patterns across the Baltic Rift arc tell you this margin is alive, slowly converging Africa toward Eurasia. In the late Miocene, the gateway wasn't a single door. It evolved from a wider, multi-branch connection into tighter throats, then likely pinched. The salt giant marks the aftermath. If it closed, how did it end? Enter the Zanclean Flood. We'll go deep on rates later, but one forensic clue matters now: the erosional scars. A 6-kilometer-wide amphitheater-shaped canyon near Malta, the incision downflow from the strait, and channel geometries consistent with peak discharges on the order of 10.8 cubic meters per second, thousands of Amazons at once. Bedrock scours, oversized sediment bodies, and basin-scale stratigraphic onlaps say the refill wasn't a trickle. It was catastrophic enough to carve and backfill in days to months, not millennia. Back to the deck of the Glomar Challenger for a second. Crew accounts from Leg 13 describe the moment cores revealed thick salts beneath deepwater muds. Surprise, a few quiet expletives, then a scramble to recheck logs. This wasn't a coastal oddity, it forced a rewrite. The M-Reflector turned the Mediterranean from a blue stable into a machine with a hidden-off switch. That switch, critically, sits at a sill that today remains comparatively shallow. One more subtle data strand: the way seismic packages step up toward margins with wedge geometries and local unconformities. They hint that water level didn't just fall once and sit, it flickered with thresholds. Some intervals show signs of reflooded conditions, marine microfauna returning, then more evaporites. That's a trapdoor mechanism in the rock. Cross the line and the system snaps downslope, cross it back and the Atlantic surges in. No drama needed, just a basin perched on delicate connectivity. So the crime scene notes read like this: basin-wide salt giant tied to a bright seismic marker, core-proven evaporite stacks, missing microfossil layers and desiccation signals, overdeepened river canyons into an empty basin, a control sill at Gibraltar in a tectonically restless arc, and megaflood scars documenting a refill with insane discharge. Put that together, and the logical verdict isn't slow, gentle drying. It's restricted basin crossing thresholds, pulsing toward desiccation, then catastrophic refill. And the trigger sits where it still sits today. File that away because the next question is timing. Was the fall gradual with a fast finale or staccato? The salts plus the canyons argue for steps, each one short enough to outrun river equilibrium. That matters because thresholds don't care about averages. They care about the exact moment a gate narrows just enough, a gradient tightens just enough, and the engine stalls. Keep your eyes on that engine at Gibraltar because the modern gauges are starting to rhyme with this file. Fast versus slow, the trapdoor mechanism. Most people were taught a slow-draining Mediterranean. Climate dries, evaporation wins, water drops, end of story. But when you line up the salt stacks, the M-Reflector, the over-deepened canyons, and the Zanclean megaflood scars, the pattern doesn't read slow ramp. It reads trapdoor. The difference matters. A ramp drifts, a trapdoor snaps. Here, what actually happens in a restricted basin with a single, shallow gate. As long as Gibraltar breathes, denser Mediterranean water spilling out, lighter Atlantic water feeding back in, the system holds. But that breathing depends on three levers staying within narrow bands: the sill geometry at the strait, the density contrast between basins, and the larger Atlantic circulation that keeps the feedstock coming. Nudge any lever past a threshold and the exchange chokes nonlinearly. You don't see a graceful fade, you see a stall. Textbooks treat the Messinian like one long drawdown because long looks tidy on timelines. The rock record won't let you get away with that. The evaporite sequence, primary gypsum into halite into potash, tracks staircase salinity. River canyons slicing far below modern base level tell you base level didn't sink politely. It stepped hard enough that rivers never caught up. And when the Atlantic overtopped, the Zanclean Flood's discharge estimates, on the order of 10.8 cubic meters per second, aren't compatible with a leisurely leak. That's a catastrophic gate failure. Atlantic water finding head, biting into bedrock, and switching the basin back on in what amounts to geologic minutes. So what trips the trapdoor? Start with the sill. The Batik Rift arc sits in slow Africa-Eurasia convergence. You don't need meters per century, you need millimeters accruing over centuries at the wrong spot. Add microseismic creep and slope failures. A slump can narrow an already skinny nozzle overnight in geologic terms. Then layer salinity physics. The Mediterranean today is saltier than the Atlantic. That density contrast powers the outflow. But if evaporation strengthens relative to inputs or Atlantic properties shift, the outflow plume densifies, the shear at the sill changes, and the overturning weakens. Push far enough, and you flip the sign on the exchange budget. In plain English, more going out than can be fed back in until the feedback can't sustain the basin. Now once you cross that line, timelines compress brutally. Evaporation over a near-closed superbasin doesn't nibble, it concentrates. Shorelines race basinward, deltas strand and cut, and the first big pulse of halite starts stacking across deep floors. That's your first step down. But thresholds cut both ways. Storm clusters, an Atlantic high stand, or a partial blockage clearing at the sill can spike inflow and pause the fall. That's how you get microfauna blinking back in and erosion surfaces between salt packages. The system tests the gate, briefly recovers, then slips again when tectonics and salinity shove in the same direction. Staccato, not symphony. Everything changes when incision takes control. As the basin drops, the hydraulic head between the Atlantic and Mediterranean grows. If the sill is even partially erodible, head plus sediment-laden flow turns the strait into a self-expanding nozzle. Early discharge is modest. But as the notch deepens, flow accelerates, shear stress skyrockets, and you blow past a second threshold. Supercritical conditions that rip a canyon into the gateway and trigger hyperpycnal jets across the basin. That's when the Malta amphitheater, the downflow channels, and the outsized gravels make sense. The flood feeds its own capacity. You might be thinking, okay, great for the Miocene, so what? Because the same mechanics don't care about dates. They care about geometry and gradients. Today, the sill is still shallow by ocean standards. The arc is still creeping. The density contrast still powers a two-layer exchange you can weaken by tightening salinity differences or by nudging the Atlantic's conveyor. And the modern record already shows the system twitching under climate variability. Mediterranean outflow water properties wobbling, the plume's core shifting, and Alboran dynamics responding to small changes in forcing. The trapdoor doesn't need a huge push. It needs the wrong push at the right time. Let me anchor this with a clean rule. In a gated basin, averages lie, thresholds tell the truth. As long as the exchange budget at the gate stays positive and the outflow plume remains buoyancy balanced, you're in the safe zone. Pinch the sill, raise effective salinity enough to choke overturning or starve the Atlantic feedstock, and you don't get a warning light, you get a mode switch. That's why the Zanclean Flood looks ridiculous on paper and inevitable in physics. Head plus erodible gate plus negative exchange equals snapback. This is the piece most people miss. Mechanism beats tempo. If the levers align, the med doesn't glide into trouble, it drops a floor. And once it drops, money, ships, and cities don't get a planning horizon, they get a shock. Hold that thought as we pull up the modern dashboards and watch the needles. The modern dashboards, are we back on the edge? Now let's pull the gauges. Start at the gate itself. The Strait of Gibraltar is a rock throttle where a two-layer exchange runs like a hidden conveyor. Salty, dense Mediterranean water spills out along the bottom into the Atlantic. Fresher Atlantic water slides in on top. That breathing keeps the basin ventilated. It only works if three things hold: the sill's geometry, the density contrast, and a stable enough Atlantic feed. Nudge any of those, and you don't get a gentle fade. You get the first cough of a stall. Geometry first. The Batik Rift arc sits on slow Africa-Eurasia convergence. GPS and seismic inversions show creep and uplift distributed around the Alboran, Gibraltar arc. We're not talking dramatic mountain building. We're talking millimeters to a few millimeters per year in the wrong places, plus microseismic slip and landslide-prone slopes on a narrow bedrock sill. The modern arc is complex rollback histories, nap stacks, but the short version is simple. This throat evolves. A little vertical change at the sill changes hydraulic control far downstream. Now the engine, density. The Mediterranean today is saltier than the adjacent Atlantic by roughly a couple practical salinity units. That makes the outflow heavier, which paradoxically powers the in-out rhythm. Heavy water goes out, pressure and mixing draw lighter water in. But the gradient's tight. Intensify evaporation during hotter, drier summers, reduce net river inputs, or tweak Atlantic properties, and the contrast tightens the wrong way. Observations in the Gulf of Cadiz show the Mediterranean outflow watercore shifting with climate modes. Studies of late Miocene restriction tie salinity flips to connectivity changes. It's a sensitive valve, not a fire hose. Layer in the Atlantic. When the larger conveyor wobbles, the headwaters feeding Gibraltar change character. AMOC variability doesn't need to collapse to matter here. A modest dip in upstream density structure or wind-driven exchange shows up at the sill as altered shear, modified stratification, and pulses in the inshore jet. The outflow plume, normally a coherent lens cascading down the continental slope, can thin, sink, or spread differently, which feeds back into how efficiently the surface inflow ventilates the Western Med. Think of it like a snorkel. Angle it a few degrees and you breathe harder. Field whispers back this story along the coasts. Deltas retreat faster than subsidence plus sea level rise alone predict. Incision anomalies show rivers nibbling at base level as if thresholds are near. In the Adriatic, Messinian legacy canyons hide beneath sediment, but modern rivers still react to short, sharp sea level and salinity swings. Around the Alboran, uplift and erosion coexist uncomfortably. None of these single threads scream catastrophe. Together, they spell a basin that responds in jumps. Okay, so where's the dashboard you can actually watch, not just infer? It's the exchange budget at the gate, the net transport balance of inversus out across Gibraltar. In practice, that's a combination of velocity profiles through the cameronal sill, density structure across the section, and the integrated salt and heat flux. When that composite slips towards zero or flips sign over sustained windows, you're no longer breathing, you're panting. Oceanographers do this with moorings, ADCPs, CTDs, and budgets that close on salt. It's not a mystery metric. It's a hard number with error bars. Here's the open loop I promised. When that exchange budget trends negative beyond normal seasonal and interannual wiggles, when the salt flux out can't be paid back by Atlantic inflow, you're in pre-failure territory. Not instant doom, a prelude. Why? Because the basin's salinity then ratchets upward, densifying the outflow further, increasing near-sill shear, and making the inflow work harder to climb the density staircase. That's textbook positive feedback in a gated basin. Cross a small structural or morphologic tweak at the sill while that's happening, and you get mode switch risk. But hasn't the Med been saltier than the Atlantic forever? Yes, and that's exactly why the gate matters. The system survives on contrast that still allows overturning. Increase evaporation and reduce freshwater inputs enough, and you tighten into a choke. Now couple that with the tectonic drift at the sill. We don't need a meter of uplift. Centimeters matter if they occur across the controlling notch or if a slump narrows the cross-section. Historic records show slope failures in straits worldwide, changing hydraulics overnight at human scales. A small slide in the wrong spot is a big deal here. Zoom out to trade math briefly because money moves before water does. Shippers, insurers, and energy desks already track med outflow indices and Suez dwell times. Why? Because an exchange-choked western basin cascades into slower ventilation, warmer, saltier intermediate layers, and knock-on stratification shifts that affect everything from local fisheries to current-assisted routing. Grain traders price weather and route risk. LNG portfolios juggle Atlantic versus Med delivery optionality. If signals at Gibraltar start trending weird, spreads widen first. That's how you'll feel this before headlines, through premiums and diversions. Last gauge, coastal microseisms and tide gauge residuals around the Alboran can betray subtle circulation regime shifts. When internal tide energy and background stratification change together, you see it in frequency content and residuals. It's nerdy, but it's a real-time stethoscope on a system otherwise slow to confess. So are we back on the edge? The honest answer, we're closer to thresholds than most people think, and the needles that matter are twitching in the same directions that preceded the last failure. Tightening salinity contrast, an evolving sill, and a big upstream conveyor wobbling just enough to matter at a narrow throat. The one number at Gibraltar, the exchange budget, ties those threads into a single trigger. Keep that number front of mind, because when it tilts and stays tilted, timelines don't stretch. Maritime arteries on a timer, trade, energy, food. Here, where a geological threshold becomes a balance sheet problem overnight. The Mediterranean isn't just a sea. It's the short circuit of 3 continents' supply chains. If Gibraltar coughs and the basin's breathing slows, the knock-ons run through Suez, LNG schedules, refinery slates, and grain receipts before anyone says, salt giant. Start with the Suez Med chain. It's already a stacked Jenga of choke points. Bab el-Mandeb feeds Suez, Suez feeds the Central Med, and the Central Med hands cargo east and west through narrow approach channels. A wobble in one block compounds across the stack. We've seen how even a single grounded hull or a week of missile threats flips freight math. Insurance premia spike, convoying slows, and ships detour around Africa, adding 10-14 days and 6 figures of fuel. Layer a Gibraltar exchange slowdown on top. Warmer, saltier intermediates, sluggier currents, more uncertain ETA windows, and schedulers bake in buffer days or choose the long way by default. That's capacity removed from the system without a single port strike. Energy next. The Med acts like a pressure valve between Atlantic LNG and the high-demand nodes of southern Europe and the Levant. Spot cargoes thread into the basin to arbitrage winter spikes, then back out to Spain, France, Italy, Greece, and Turkey. A ventilation choke doesn't kill deliveries, but it amplifies meteorology and draft constraints into reliability risk. When reliability drops, underwriters move first. War risk writers expand into route risk. Lenders, covenants ask for alternative port options, and charterers demand premium day rates for crews willing to eat uncertainty. Traders front-run that with wider bid-ask spreads at Greek and Italian markers, and marginal molecules peel toward Atlantic basins where laytime is predictable. Net effect: fewer flexible cargoes into the Med, more price volatility at the edges. Crude and products feel it too. North African grades and Eastern Med sweet barrels reach European refineries through approach channels that don't love long-period swell or odd stratification. If the basin grows more stratified and internal wave energy shifts, you get more weather holds at exposed terminals and tighter operating windows on single buoy moorings. Add Suez variability, convoys tightened, canal fees repriced, or precautionary slow steaming, and refiners hedge by raising inventories or pulling more from the North Sea and U.S. Gulf. That reweights pipelines and product tankers through the Atlantic, bidding up freight and cracking margins. You don't need a drought to move a diesel crack. You need planners who can't trust schedules. Now the fragile one, grain. The Black Sea to MENA corridor is one of the quiet backbones of food security. Wheat, corn, and sunflower oil inbound to Egypt, Algeria, Tunisia, Lebanon, and beyond ride predictable slots through the Bosporus, across the Central Med into shallow draft ports that juggle swell, silt, and bureaucracy. Climatic hits already shorten harvests, route hits multiply price. If exchange at Gibraltar signals instability, more delays, fewer willing hulls, higher insurance, Some owners refuse fixtures into the basin at standard rates. Freight blows out by dollars per ton, which at MENA volumes translates into budget holes for importers and price lifts on the street. A 10–20% swing on landed grain isn't manageable for subsidy-stressed treasuries. It's rationing pressure and political noise. Fertilizer is the hidden fuse. Nitrogen feedstock, gas, and phosphate chains cross this sea both ways. When LNG availability wobbles and voyage times stretch, ammonia and urea shipments shift timing and planting calendars slip. That misses yield windows. Even if you can buy the grain, you're chasing less of it. Food inflation becomes sticky because you're now solving logistics at the same time you're fighting agronomy. Ports and insurers price this early. Dwell time becomes the KPI to watch. If average box or bulk dwell at central basin ports trends up and stays up, terminal operators move to congestion surcharges, lines trim calls, and feeder networks fray. Draft limits creep tighter when swells and set down events force conservative pilots. Shippers re-rate reliability and push cargo inland by rail where possible. Iberia to Benelux, Italy to Bavaria, Maghreb to inland Morocco. Rail gets loved quickly when water gets weird. Fleet behavior is the tell. Owners shift tonnage lists away from ports with rising weird water days, more no-go windows from internal waves, more last-minute pilot cancellations, more tug unavailability and bad chop. That quietly lowers effective capacity in the basin. Rates rise first on marginal routes, then bleed into index benchmarks. You'll hear it as Mediterranean premium long before anyone blames a sill. This doesn't stay regional. When Atlantic ports pick up volume shed by central basin uncertainty, their yard productivity and truck turn times get tested. Azores and Madeira look less like postcards and more like mid-ocean waypoints for rerouting and bunkering. Red Sea pivots absorb Suez slowdowns but inherit risk. West African and U.S. Gulf exporters gain share into Europe, pushing different sulfur, octane, and blending specs, which refineries must chase or pay up for swaps. Okay, so what do players actually do when the needles twitch? Traders widen spreads and pre-position inventory outside the basin. Insurers rewrite exclusions, push rates, and blacklist terminals with rising incident frequency. Charterers bias to ships with dual routing optionality and crew comfort in difficult waters, paying for it in day rates. Governments quietly negotiate state-to-state liftings for grain and fuel, jumping queues. And capital, it follows reliability. Inland logistics assets and Atlantic-facing terminals re-rate up. Central basin, shallow approach ports with silt problems re-rate down. The headline will say supply shock. The footnote will be Gibraltar exchange trend flipped 3 quarters ago. That's why we planted that one number. Money moves before water finishes the story. And when money starts moving, people do too, which is where we're heading next. The human pivot, migration, brain drain, city risk.